All right, let's do number 15. Okay. Water evaporates. Evaporated means changing to the gas, right? Menguap, penguapan. From the water, from the liquid to the gas. That's evaporate. Menguap, yeah? So it means this water is reducing here. This part is reducing. That's why the heights become like this. So from, we know this is a half of sphere. That we call a half of sphere is a hemispherical bowl. The name of that half of sphere. Okay, here is with the radius r and the rate. Remember, the rate is the rate of change. Remember, rate of change is talk about the difference between two quantities. So derivative or differential, the difference is differential of any function. Relate to this is the volume. The function is volume. Respect to what? Respect to the time, respect to the height. Yeah. So depends to the case. It could be respect to the time, respect to the height. So it means there is a change in this situation. The full container here, this is container since this 3D, is reducing until this after evaporated. After evaporating. Next. Continue. Where T is time in hours units. So the volume of the water of that H in a hemispherical bowl of radius is given this. Okay, that's the given here. Question A. Use this equation, differential equation, of course, because there is dd in terms of d derivative. That's differential equation. Okay, this dv dh, and then you derive again this dh dt. That's we call chain rules. So you derive the biggest function volume v to the, let's say you do to the height, and the height you derive again. Derive the height, it means the height is changing. The height is changing, is reducing from this height, yeah, become this. So it means the height is changing. Derivative changing is derivative to the of course to the time, because changing using time. That's dv respect to dt. Why? Because if you see this, you notice that one, this you can cancel, right? And it's gonna be written over dt. dv over dt, this one. That's what we called as chain rules. The biggest function, and then you derive it to the variable, and that variable you this one, the h, you derive it again to the other variable. This case is the time. Okay, clear? Let's go to the question. What's the question asking? Use this equation, differential equation, to write a differential equation connecting to the h, t, and r terms, in two terms h, t, and r, which is r is a constant. All right, let's do it. Clean this first. Okay, let's do it. So A, I'm gonna use here. So if you have volume equals to 1/3, what is that? Check again. 1/3 pi h square, brackets, parenthesis, 3r minus h. Okay, so before you derivate this respect to the variable h, that's the questions. We need to do that because dv dt is given in the question already. This dv dt is already given this. So you need to find this part, which is derivative to the height dh. Okay. So this, check again. So 1/3 pi h squared brackets 3r minus h. Correct or not? Yes, correct. Alright, let's derivate. So let's derivate respect to the variable h. So it means you have to take a look the h variable. That's the variable. So it means the other symbol, this constant, the pi, and the r also constant. So only this variable. Because we derive to the h. That's the meaning. Only look to the variable h. So dv respect to or respect with variable h. So you need to do expansion first here to open the brackets. That's expanding. So 1/3 times 3 is 1. Pi times h squared times r. So now we have pi r h squared. Let's go to the second term, the inner one times the h. So 1/3 minus 1/3 pi h squared h. So pi h cubed. Sorry, this is still v, yeah? We didn't do the derivation process yet. So it's still function of v of h, pi r times h squared minus 1/3 pi h cubed. So let's do derivative of this. So dv of h respect to the h. So take a look to the variable h, this and this. So the rest is constant, this constant. So 2 over here, so 2 pi r h 2 minus 1, because this minus 1, right? When you do derivation, minus 3 times 1/3 is 1 pi, the constant, this power minus 1, so h power 2. So now we have simplest form 2 pi r h minus pi h squared. So that's the derivative of volume respect to the variable height h. Okay, so that's the answer. Not yet, yeah, we're not done yet. The question asking you need to use this as the to find a differential equation, a new differential equation. So this we got just now, and this in the question, this negative r squared. So dv respect to dt is negative r squared equals to dv over dh, this one, 2 pi r h 2 pi r h minus pi h minus pi h square, and times dh and then that's times dh over dt. Why? Because this is not given yet. So this is gonna be as the differential equation. We're gonna pop it by using this differential equation. So we use that dh over dt. Why? Because that's the question said a differential equation. So we're gonna use dh over dt. That's differential equation. Oops. This differential equation. So equals to, because this is multiplication, so move this to the bottom of this r square, negative r square. So this move to this cross multiplication on here place. So negative r square over 2 pi RH minus pi H square. All right, that's the differential equation is answer. If you want to turn into positive terms, so you just times by -1 the numerator and denominator, so it's gonna be plus r square or positive r. Yeah, oops, sorry. So it's gonna be, if you times -1, so it's gonna be r square positive 1. And if you times negative all of this, so this is gonna be positive, negative times negative positive, and this become negative. So it's gonna be 2 pi RH. Oops. Times -1 all of them. So this is gonna be over. This is gonna be positive because I times by negative times negative. So pi r pi h square, and then this is gonna be negative minus 2 pi r h. So this is the differential equation. So now we have a new differential equation is this derivative differential equation of h, hold on, respect to dt equals to this r square over pi h square minus 2 pi rh. That's all done. So a differential equation connecting to the h, t, and r. T, h, r. So it's answered. Okay. So keep it this one. It's gonna be useful for the next question. Let's go to the part B. What's the part B? Suppose the ball's radius, so the radius of the balls, it means the hemispherical balls. The radius is this, 10 centimeter, yeah, Kevin. And initially the ball is full of water. What does it mean? At the beginning, initially, it means the time still not running, so still t is 0. The ball is full of water, so the ball still full of water. But if it's reducing, it's gonna be this, because it's already into differential equation. That's the meaning of the rate of change. Yeah. And then from this statement, the question asking, show the time is equal of this. All right, let's do it. So time it's got from this part before. Where is it, the time? Oh, we have done yet, guys. This times dh dt. dv dh, this one is done already. Oh, guys, sorry, we have to use dv dt here. Hold on. I did, right? Hold. Already. dh dt already. It's already differential equation. Okay, now I'm gonna use this to answer the time. So how to take the time only? This differential must be integrate, right? But before you integrate this d to take only time, so you need to do separable integral, yeah, by joining the same term. So if this h, oops, if this h, so this join with the h, so do cross multiply because h joining with the terms of h and r square with the dt. Let's go. So dh over dt, I'm gonna use here dh over dt equals to the first part that we got before this, r square over vh square minus this r square over vh square minus 2 pi r square vh square. Oops, where is it? vh square vh square minus 2 pi r square 2 pi r square. What? That's different. Where is it? Okay. Ini 2 pi r 2 pi rh or 2 pi rh. Okay. So let's check r square pi h square 2 pi r. Okay. Now do separable method, joining the terms h with h join in one place. So I'm gonna move this cross multiply to here. So pi h square minus 2 pi rh dh equals to r square dt. So now we're going to show the t, not dt. How? By integration. So we can cancel this with this integral. So now you get r squared times t. So if you do integration on the right side, you have to do on the left side. So integral pi h square minus 2 pi rh respect to dh. So integrate h, that's the meaning, connection to the h variable. So if you integrate this one, so 1 per 3 pi h cube minus this 1 plus 1, so 2 over 2 pi rh square. Yeah. So cancel this, equals to r square plus times t. This is plus c, don't forget, plus c. We're joining the c here together on one c. So no need to write this c. Alright. So simplify. So now we have 1/3 pi h cube minus pi rh square equals r square times t plus c. Now you want to find the t. So t equals to, we want to find the t, but we need to insert the c, right? So by using what? The a say that the radius 10. Yeah, the radius is 10 Kelvin, yeah, and initially time is 0. So let's insert here to get the c. So let's insert this one, still 1/3 pi h cube minus pi, radius is 10 times 10 centi times h square, radius is 10 square is 100 times t, yeah, times t is 0, so plus c. 'Alright. So now you have 1/3 pi h cubed minus 10 pi h squared equals to c. Okay. The height in the question also given. The height is the depth. The depth. Where is the depth? The volume of the water depth is symmetrical, where it is given by the differential equation. Suppose the ball, and initially the ball is full of water. So the depth, the rate is 10. Okay. Let's see, go to the T already. Where's the question? Okay, here. So now we have, if the radius is already 10, insert. So now we have the C. So 1/3 pi, the depth is 10 cubed minus 10 times pi, the depth 10 square equals C. So 1000 pi out of 3 minus 1000 pi. So if you put it into per 1, do cross multiply, and then you have 1000 pi minus 3000 pi over 3. Oh, now you have negative 2000 pi over 3. That's the C. Okay. Okay, let's go. Now we got the C. And then now we go to the question again, come back to insert the C. This. Okay. So now we put C equals this, move to the left, minus, yeah. So 1/3 pi h cubed. So we have before 1/3 pi, what is that? Pi h cubed, yeah. Minus 10 pi h square equals to 100t plus c. And c equals to 1/3 pi h cubed minus 10 pi h square minus 100t. Okay, so now insert the c. Yeah, the c is 100. The c, negative 2000. Where is it? This one. Okay, negative 2000 pi over 3. So now we have if we arrange this number, move, because we need to find the time, let's move this to this one to separate the t, because we want to find the time. So c get inside, negative c. So 1/3 pi h cubed minus 10 pi h square. So let's insert the c. So let's see, 1/3 pi h cubed minus 10 pi h square minus, the c is negative 2000 pi over 3. 2000 pi over 3 equals 100t. Okay, we need to find only t, time. That's the question asking about. So let's we divide by 100 this one. So if divide by 100, this is times 100. So divide by 100, and this is divide by times 100, right? Am I right? Yes. So now we come pi h cubed over 300. minus cancel, pi h square over 10. Yeah. Okay, check. Okay, then this cancel with this cancel, 20 over 3. Negative times negative, positive 20 over 3. Or just put it into 2000 first, yeah, 2000 over 300 pi equals to t. Cancel, cancel. Okay, now simplifying. So let's divide this with this, taking as the let's say this term pi. Let's take the scale factor pi, put the brackets, and this is 300. Let's take 300. So left here only h cube minus. So if you're taking 300, this is supposed to be you take it, so it's gonna be 30. Yeah, because 30 divide this is 10. That's 10. So 30 pi h square. I took the pi here, so I don't have to write the pi here. Only 30 h square. And plus you take out this part, so left only 2000. That's t. Okay, and then that's the t into function. So t, and it's proved. It's only proving, right? Let's check. Yeah, it's proving. So correct. H cube minus 30 h square plus 2000. Check. H cube minus 30 h square plus 2000. That's t. That's only proving, right? Times this pi over 300. Okay, it's answer. Let's go to part 2. Find the time taken for the depth of the water to fall to 5 cm. So the depth to fall to 5 cm, it means the height is 5 cm. So when the height is 5 cm, so you insert 5 cm here. So the height 5 cm. So this is 5 cube pi over 300 minus 35 square plus 2000. And the time equals to, so pi per 300, 125, yeah, pi 525, 25 times 5, 25, yeah, 125 minus 30 times 25 plus 2000. So now pi out of 300. So 125, 32 minus this, 75 plus 10 plus 2000 equals t. So this minus this, 100 is 600. 600 minus 50, 625. 625. And then 2000. This minus. Okay. So become, hold on, 525, 30 h square, 30 h square, 25. Okay, 75, 750. This minus. So 600 minus 625, 125, 750, yeah, minus 625, 2000 plus negative 625 minus 5 9 7 9 3 1. So positive 137. Okay, so you got the answer pi out of 300 times 1375 before. In terms of pi, that's the t. Okay, 1375 pi over 300. In terms of pi, that's the time. So if you times this, the pi, so it's the t is approximate to, I use calculator here. Here's the IB calculator. 1375 times 3.14, and then answer divide 300. 14.39. So round it to one decimal place, 14.4 second. Not second hours The question said hours, as I know. So the water, that's the question said that what? Where's this Parsi? It's the C one, So the time taken 14.4 hours for the depth of the water to fall 5 cm. So to fall 5 centimeters the depth. So it's taking time 14 hours, 0.4. Okay, let's go to the 3. How long will it take for the bowl to empty? Jadi berapa lama waktu yang dibutuhkan? How long will it take for the bowl to empty? Untuk jadi kosong, kira-kira waktunya berapa lama? Gitu ya. That's the question asking. So it means to bowl to be empty. What does it mean? Bowl empty, it means the height is equals to 0. That's the meaning of bowl to be empty, or to be emptied. That's the meaning, height 0, isn't it? Because empty, right? No height. That's the meaning of that. So let's move to that. So h equals to 0, and we have time before. What's the question again? Okay, how long it take to the empty? All right. So just insert the height to the equation. You go to this, the time, the height is 0, 0. So you just have this finish. So this pi over 300 times this. That's the time, because the height is empty, right? So you have, okay, so just use this one, this and this, because this 0, 0. So times equal pi over 300 times 2000, because the height is empty. H is empty. So now you have time is cancel. Now 20 pi over 3. So when height is 0 or the bowl is empty, the time is, it needs to be taken about 220 times 3.14, the pi over 3. Let's use calculator. 20 times berapa ini? 3.14 and divide by 3. 20.933 rounded off, 20.9 hours to be empty, or to empty. That's the time to take it, the bowl to empty. Okay, that's all. Thank you.